It's a beautiful day in this neighborhood, a beautiful day for a neighbor. Would you be mine? Could you be mine? It's a neighborly day for this beauty wood, a neighborly day for a beauty. Would you be mine? Could you be mine? I have always wanted to have a neighbor just like you. I've always wanted to live in a neighbor.
Well, good morning there, neighbor. Nice to see you today on this wonderful morning. I hope you're having a good time and that you're really enjoying this pleasant day. Because I want you to know that I feel that you're special and that I really appreciate you. Let's get to math. Bear with me because I forgot my mouse. Remember, okay, so this is really a good cumulative practice for chapters 1 to 3. Draw a horizontal line of prime factors less than 25. And I'm not going to really give you tons of answers on these because I also have the answer key on and attached. So I'm just going to give you bits and pieces, and then I want you to check. Hey, look at that beautiful line. I want you to check your work. So prime numbers less than 25. Remember, prime numbers are numbers that have factors that are only one in itself. So we would start our horizontal number line. And if I wasn't on my crappy computer with my crappy annotating that would change everything I did, I'd probably put some arrows on the end. Obviously we know that a number line for us on this would probably start with a 0, and I bet you it changes to 2. Of course it does. We'll try one more time, and then at the end of it I'm going to put a 25. Hey, it worked. And then I'm going to write the prime numbers less than 25 on our number line. Less than 25, which would be like maybe 1, 2, 3, 3 prime numbers, and then you can finish it. So 2, 3, 5, 7, 11, 13. Okay, you guys can handle that one pretty easy. Okay, and then number 2 is just you writing a number line of what it says. Mixed numbers between -6 and -7. So again, we're going to write a flat number line between -6. So our bottom is going to be, you guessed it, -6. Let me make sure I do a few circles. And our top, you guessed it, everyone's favorite number, 7. With an interval of 1/5 between each pair. So if it's saying an interval of 1/5, that means, remember, we're going to add 1/5. So if this is -6, then the first number would be 6 and 1/5. The next one would be -6 and 2/5, -6 and 3/5. Okay, and you continue on that. You should be able to get these least to greatest pretty easy. Just remember that where you have 0, everything on that side of the number line is negative, and everything on that side is positive. So one of the key things to always remember that. And then you have another one here. Complete each of the inequality. I guess you could always pause it, and then you could check your answers right now. That's a good idea. And then I'm going to continue going. Complete the inequalities. So these actually aren't 6th grade math standards right now, and I did not teach them to you. I was told that you will focus on them in 7th grade, so I didn't teach you square roots and cube roots and all that jazz. However, you should be able to get these and tell me what is greater or less than on all of these. Especially this one. And don't forget, the exponent, again, is that number times itself however many times it is for the exponent. So 3 to the 3rd power is 3 times 3 times 3. 2 to the 4th power, hey, is 2 times 2 times 2 times 2. Sorry, I just saw that good-looking guy with that beard, fresh haircut. Dang. And then think of the absolute number of negative 80, negative 100, 600, negative 700. And then we'll keep on moving. So pause real quickly, check that stuff out. Perfect. So number 15, express each number as a product of its prime factor. I'll do one number 14 just because it's easier for me. Because it's way over there and I got more room on my iPad. It's not an iPad, it's a Mac. Jeez Louise. It's my mom's middle name. So we've got 180. Remember you draw this. It really could be whatever you want. I like to hide the 0 and take it out. And I say, okay, well, what makes up 18? Well, I know 6 times 3 equal 18. So I'm going to bring my 0 back. And then I'm going to say, I'm going to do a couple circles. Oh, let's do 30. So 6 times 30 will equal 180. That works good. So remember, this is the prime factors. We're doing the factor tree. So then off the 6, I have 2, or a weird C, and 3 again. These are my prime factors. If I could draw a cool circle around them, totally will, and I did. And then we can still get smaller with this. I know that 15 goes into 30. Yes, it's a 2. And then I just keep going. Okay, so I know that 2 is a prime factor. So I'll do my circle. And I know that I'm going to keep going with 15. And 15 would be, pardon my crappy arrows, 5 and 3. Yeah, those ones aren't bad. And then I would again circle those. And then make sure, since it says that it's a product of its prime factor, that you're looking for it to be a product. A product is the answer to a multiplication problem. So I'd say 180 equals 2 times 3. Actually, sorry, put them in order. 2. Actually, I'll just write it. 2. Well, I can't, I guess, with these terrible thingamajiggies. However, I guess I'll have to be like you guys, huh? Oh, yeah, let's do that. Okay, I want that. Okay, but is it going to let me? Nope. I haven't done a text box yet. It's kind of like, why won't you let me? What do I need to do to select it? I don't want to send or anything. Give me Luminari, because you guys are into that Luminari stuff. Okay, nope, not going to let me. Oh, well. Just put the like ones together, right? So 2 times 2 times 3 times 3 times 5. So 180 equals those. That's a product of its prime factors. Product is an answer to a multiplication question. So then you should be able to do the same thing for 13. And then greatest common factor. You can also do this prime tree of our factor tree to find those for that. And remember, if 24 and 48 both have a 3, you only need to have 1 3. So you just eliminate all the extras that they have. And it's factors, not multiples. Remember, factors are what make a number. Like 2 times 3 is 6. Multiples, if we were just using 6, for example, 2 and 3 are factors of 6. When we're talking about this common multiple, that's when you take 6 and you say 6 plus 6 plus 6 plus 6. Multiple of the same number. It's easy to get those confused. So then make sure you're doing that right. And so you should be able to do 17 and 18. You can do all of these with a factor tree. It is a lot harder if you don't remember how to do that. If you're doing the factor tree with common multiples, it's a little bit more challenging. I'm not going to show you because I don't want to confuse you if you don't remember how to do it. Find the value of each of the following. We did not work on 19 through 24, so you can skip it. I will double check and verify that we don't need to do those on the state testing. I'm just basing it off of what we talked together as 6th grade teachers, that is 7th grade math work now, because this math book is old and not very good. Okay, so you should be able to do these. Remember, the easiest way to get these done is to not leave them as a mixed number, but to put them into a improper fraction. And let's see if I can zoom in really close. And I think the easiest way to do this is to always, multiply. I knew it was going to make it big still. Do I need to move my face? There we go. You multiply and then you add. Okay, if you do those two things, that's how you really are going to get rid of these as mixed numbers. So 5 times 2 is 10. Add 2. All you're doing is you're saying that these two wholes, remember, are 5/5. So you have 2 sets of 5, 5. That's why you multiply. 5 plus 5 is 10. Well, this is your extras, so you add it to your wholes. So you get 12/5. Your bottom stays the same unless you change it. And then multiplying fractions is as easy as just multiplying across. So then you'll just do it that way. You end up with your answer. La-di-da-di-da. Let's not have it too small. And then the only thing that you're going to do differently on 6 is you're still going to multiply. It's a lot harder if I'm not close. Add the 5. Right? I'm just going to delete it. You get the gist. And then keep, change, flip. Remember? So you're going to have this as an improper fraction times, and then you flip it. And hopefully that you remember how to do the decimals. Decimal division. First off, I know that I remember a lot of us were struggling on how to even actually set that up as a division problem. Well, remember, this is 18.5 divided by 2.5. So we need to actually write 18. Do cursive, I bet it works better. 18.5. Oh, come on. I was really hoping the smaller lines would be better. I mean, that's a pretty good looking 5. If it changes this, I quit. That's right. You gotta set these up. You gotta set yourself up from the beginning. This is 18.5, 18 and 5/10, 18.5, whatever you want to call it, divided by 2.5. Okay, that means you're putting this divided by, and then having 2, and I'll quit. That's a good looking 5. Man, just gotta throw some threats out there and this thing works for me. And then from here, you're going to take your decimal, move it out one time. I gotta love doing this sometimes. And then you do the same thing the other side, move it out one time. And then remember, think of quarters on this one. And that should help you out. I'm going to put those back. So the only way that I was thinking of that sometimes you guys would write it would be you'd actually have it like this. And then you'll take this and you'll put it there like that. So 2 different problems. You've got a really high number, 18.5, divided by 2.5. When you write it wrong like this, you're saying that you're taking 2.5 divided by 18.5. So you're like taking 2.5 pizzas and you're dividing it by 18.5 people. That's a huge difference than if you have 18.5 pizzas and you're only dividing it by 2.5 people. I think I'd rather split 18 pizzas with 3 people than 2.5 pizzas with 18 people. Although the second one actually makes more sense. That's because that's how I made it up. Ugh, don't hate me. Pause for you to check it. So then just make sure you're getting your answers right. You can pause this if you need to. Hopefully you got the papers. Okay, number 29. The mass of a bag of flour is 7 kilograms, 500 grams. Joyce repacks the flour into 12 small packs of equal mass. What is the mass in kilograms of each small pack of flour? So 1 kilogram equals 1,000 grams. So right off the bat, it's telling you we want to know it in kilograms. And it doesn't really do a good job of basically explaining to you that that number is 7.5. It's basically 7.5 kilograms, right? Because 1 kilogram equals 1,000 grams. So we could even put like that, so then it makes more sense. And then we have that, and we need to divide it into 12 equal packets. So if we drew our picture, that's like saying we have this, okay, and our whole here equals, not that, that's a weird line. Come on. 1, 2, come on, it's like a bird. Perfect, thank you. And then I don't have enough time to do this perfectly. I mean, I guess I have all the time in the world, but not for your videos. I'm just going to make 12 lines. You don't have to do this. This is just me trying to explain it to you. So if I'm making these 12 lines, I'm saying that 7.5 is divided into 12. So divided, split means divide. I don't think I can make it easier than that. So then you're just going to divide that number by 12, and that tells you what 1. And remember, if you know what 1 is, you should be able to figure out what 2 is, 3 is, or 12. Pretend there's 2 more. I know I was only gifted with 10 fingers. Actually, 8 fingers and 2 thumbs. So then that should give you your answer right there. 29 would be 0.625. And hopefully you realize that you don't really need these. The zeros at the end. We talked about that in class. So really you have 7.5 divided by 12. So moving on. So a chef buys 4.5 pounds of broccoli. Well, let's put cheese on it. Like broccoli and cheese, and it has to be steamed broccoli, is my jam. Regular broccoli just gives me gas, and then you don't want to hang out with me. And then the casserole calls for 3/4 pound of broccoli. How many casseroles can the chef prepare before she runs out of broccoli? So this can be done just by doing something as easy as this, right? Oops, nope, V. Just to show you a picture, okay? Because I like really showing pictures just so that they make more sense. Because to me, pictures can really help us understand math better. So I've got my 4.5 pounds, except for I need to draw a line on one of them to show you that this one is my half. Okay, so if we're taking 3/4, so if this is 4.5 pounds, right? So the first thing you got to do is really make them all the same. So if I'm gonna say it's 3/4, well, I'm gonna draw. Sorry, that looks terrible. But pretend that those lines actually go through the whole thing. So all of them have 4 parts. Just not that good. And then on this one, just know that it's still half. I got to do the same over here. But it's clearly just these two. These two don't matter because I don't have them. They're out. So now everything's split. So this is kind of like drawing that number line if we went like this. And we went from 0 to 4, or not 4, probably 5. It wouldn't be 4 because you have that extra half. So, and then this just kind of represents like that 1, 2. You see what I did? 3, 4. And then since we're taking out 3/4 of a pound, we're sharing it, you're dividing. So you could also do 4.5 divided by 3/4. And then you're just going to take out 3/4. Every 3/4. So that's like Nope, don't do that, dude. Okay, so like there's 3. There's 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Oh, look, perfect. A perfect amount, I hope. 1, 2, 3, 4, 5, 6. We were able to get 6 exact 3/4. How many casseroles can he make before she runs out? I said he, and it's a she. How much can she make before it runs out? 6. We can verify our answer. Number 30. 4.5 divided by 6, or 3/4 equals 6 casseroles. So this shows you the other way that you could do this. And remember, it's just what you just got done doing on another problem. Turn it into an improper fraction, and then keep change float. So you got 31, 32, 33, 34, 35, 36. So you still got a lot left. Why don't you pause? And then I will do a couple of them, and then try to do a couple of these on your own. And if you're stuck, well, then you can go ahead and just keep going. So here are the answers if you want to pause and look at it real quick. I do like the word problems on these because it does tell you how to do it. So on 31, you get your 3 units, 1 unit, 5 units. It tells you what it is per kilogram, and kind of how to solve it. Okay. So one of the ones we're going to work on is 32. So Paul paid, man, I was frozen on a smile. That's creepy. Paul paid $25.50 for 3 cups. So I went ahead and drew my 3 cups. Then he also had 4 cups of hot tea. So 1, 2, 3. Ugh. Without a mouse is hard. And I'm going to just put a T in here. Just so you guys know that that's the T. Versus the hot chocolate. So 1, 2, 3 to 1, 2, 3, 4. So it says the cost of each is 2/3 cost of hot chocolate. So if we look at that, so if this is, sorry, maybe if I do it this way, and then watch this, we're gonna own this, and then we're gonna take it down here. Ha ha ha. Wait, no, that's 4. That's not what I want. There we go. So if we just look at this, right? So we know there are 3 of these. So we're saying that each cup of tea is 2/3 the cost. So 2/3 is how many? Exactly 2. So we're going to draw a 2 terribly. So we know that for each 3 parts, this is our ratio side. Okay, this is where this part comes in handy. For 3 parts of hot chocolate, you get 2 parts of tea. So if there's 2 parts for 1 set of tea, that's 2, 4, 6, 8, right? So we know that total in tea, there are how many total parts? 8. For hot chocolate, well, what would you get there? Wake up. We would just do the same, right? So if we counted 2, 4, 6, 8 for 2, well, then we would say that each one of these is split into 3. So 3, 6, 9. So how many total parts would we have drawn? That's an add sign, by the way, and not a hourglass. That's a real 9. There you go. No. Well, yeah, I'll do it 5 times and then go down. Not amused. Not today. So I guess that looks terrible though, because I know someone's be like, I multiplied them because your sign looked like a multiplying sign. There you add. So if you have 8 over here and 9 here, remember they're all the same, because we made them the same, right? So there's 17 total. So again, if you think of this as a whole then, and we said there are 17 total pieces here. So 25 and a half, and then we're going to divide that by 17. Okay, if I can actually do it. So 17 goes into 25 once, 25 minus 17, and then you can continue it. You're going to end up with $1.50. Okay, so that tells you for one thing is $1.50. So if we only need 3 of them, well, $1.50 plus $1, because it wants hot chocolate, right? And this is hot chocolate. So $1.50 plus $1.50 plus $1.50 is $4.50. Hopefully I did enough work for you out of that. The only thing I didn't complete was just doing the division work, stuff that you should be able to do. And you end up getting this. So then I know that, well, 17 divided, this is 17 parts, because we got the 8 and the 9. Well, then each part is $1.50. If there's 17 of them, right? And then we'll check our work. Number 32, each cup of hot chocolate was $4.50. So if there's, each cup was $4.50, what was the total? That would be your other question. Because it just wanted to know each cup of hot chocolate. So I actually did it wrong when I told you that it was 333, because remember, we did 17 parts. So there are 3 sections here. Each one of these was $1.50, $1.50, $1.50, $1.50. Got it? Because the T is 2/3, so it'd be $1.50, $1.50. So $3 is 2/3 of $4.50. $4.50. Okay, let's look at number 30. Let's do 34. So this is kind of a fun one. So a cereal bar is sold individually, frozen. There I am. For $2.46, or in packs of 4, for $8 per pack. Roxy wants to buy exactly 38 bars of cereal. What is the least amount of money that Roxy can spend? This is a pretty easy one. So what I would do, I would say, and first off, why are you going to have exactly 38? Why not you just have 40? You know what I mean? Then you might get more. How many times does 8 go into 38, right? That common factor. Well, I know, I just said 8 goes into 40 5 times. So 8 goes into 4, or 38 4 times. So I'm going to have 4 packs of that. So 4 times, well, 4 for 30. I'm going to buy, I'm doing this wrong. I'm doing the whole $8 thing. 4 for $8. I need to go, how many times does 4 go into 38? See how Mr. Runyan even messed up thinking because you put in extra numbers, etc. It happens. Sometimes you just got to slow down and think about it a little bit more. So 4 for $8. I was thinking of the wrong number. I was thinking, like, why would you spend that when you can just do this? But I wasn't thinking. So 4. How many times does 4 go into 38? Well, 4 still goes into 40, right? 4 goes into 40 10 times. That's too much. So we actually want to do 9. And then, or hourglass, whatever. And there's 2 left over. Man, this thing really hates me this morning. Ha. And ha. So we'll have 9 packs of the 4, because 9 times 4 is 36, 37, 38. That's exactly 38 bars. Okay. So if I'm buying 9 packs of that, 9 times 4 is 36. What's 9 times 8? 9 times 8 is $72. It's a lot of, man, it must be some good bars. It's not a 71, by the way. It's just a crappy. There you go. And then I have 2 left. Well, two 240s. I like to split them up. 2 plus 2 is 4. So that'll actually end up changing our crappy 2 to a 76. It didn't change it. It's a Halloween miracle. So 76. And then a 40-40 would be 80. So you should end up... Oh, see, there it wanted to correct me and say, no, it's not 88. It's 80. 40-40. So $76.80. And we can check our work. 34. $76.80. Hi. Welcome back. I'm frozen again. Okay, so after doing that problem, if you just look at the answer key for most of these, I think it's probably just as beneficial. You should be pretty close to an hour now. So the answer keys for the word problems on this are amazing. So do your work, come back here, reference the answer keys. It kind of gives you a good idea of how to do it. And then we'll hopefully set you up for success for our test next week. Have a good weekend.